evaluate the limits. In A, the limit as x tends to 4 of x squared minus 16 over x minus 4. Now, in a situation like this, we cannot simply take the value that x tends to and substitute it in, because 4 minus 4 is 0. We cannot have a 0 in the denominator. So 4 is actually a non-permissible value for this rational expression. And we can see that we have the same scenario in C. We cannot just simply plug in 0 in the denominator. The same thing in D, and the same thing would happen in E. So in situations like this, what you need to try and do is to simplify the expression, in this case this rational expression, and then evaluate the limit once you have a simplified form. So here we have a difference of squares in the numerator, so we can go ahead and factor that. So we're going to get the limit as x tends to 4 of x minus 4 times x plus 4 over x minus 4. So now we can see that the x minus 4 cancels the x minus 4 in the denominator, and we're left with the limit as x tends to 4 of x plus 4. Now we can substitute in 4 for the x and evaluate this limit. So it's going to be 4 plus 4, which equals to 8. In B, we don't have this problem. We can simply plug in and substitute in 1 for the x. So it's going to be 1 minus 1 over 1, which is 0 divided by 1, which is 0. So in this case here, the limit as x tends to 1 of x minus 1 over x equals to 0. In C, we need to try and simplify this. So the way we're going to do that here is we're going to multiply the numerator and the denominator by the conjugate of the numerator. So that's going to take a bit more space. So I'm going to do that down here. So in C, we have the limit as x tends to 0 of the square root of x plus 4 minus 2 over x. We multiply numerator and denominator by the conjugate of the numerator, which is going to be square root of x plus 4 plus 2. Same thing in the denominator. So all we've really done here is that we have multiplied the original expression here by 1. So nothing is really changing. But this allows us to simplify this expression. What we now have in the numerator, so this together with this product, this is a factored difference of squares. So we can now go backwards and create a difference of squares from those two binomials. If it's easier, we can put brackets around the numerator. So now what we have is the limit as x tends to 0. In the numerator, we're going to get square root of x plus 4 squared minus 2 squared. In the denominator, we leave that in factored form like this. It's just a product of a monomial and a binomial, like that. Now we simplify the numerator. The squaring of a square root just eliminates the square root. So in the numerator, we're going to be left with x plus 4 minus 4. In the denominator, we want to keep that in factored form, so it stays like this. And now we can see that 4 minus 4, that just cancels out, that's 0. And then we're left with just a single x in the numerator. And there's also an x here, so those cancel. So what we're left with now is the limit as x tends to 0 of 1 over square root of x plus 4 plus 2. And now we can substitute in 0. We're going to get 1 over square root of 0 plus 4 plus 2. So this is just the radicand is 4, square root of 4 is 2, 2 plus 2 is 4. So the limit here is going to be 1 over 4. Right? In D, so if we take a look at D, we cannot simply plug in x equals -6 because we would end up with a 0 in the denominator. And we cannot actually simplify this in any way. So it means that in this particular case, there's nothing really we can do. There's no solution to this. It's an empty set. Okay. In E, we need to simplify this. So I'm going to do that on a separate page just to make sure I have enough space. So in E, we have the limit as x tends to 7 of the following expression, x minus 7 over 1 over x minus 1 over 7. So we're going to start here by cleaning up and simplifying the denominator. We're going to actually perform that subtraction. And of course, when we're subtracting quotient, we need the same denominator. So we have the limit as x tends to 7. For now, the numerator stays the same. In the denominator, we're going to put it on a common division line. Denominator, the lowest common denominator is 7x. And in the numerator, we're going to get 7 minus x. So we have this division of quotients here. We're going to get rid of that by multiplying by the reciprocal of the denominator. Sorry, that's wrong. I should say limit as x tends to 7. Okay. And then we have x minus 7 over 1 times the reciprocal of the denominator, 7x over 7 minus x. Now, these two binomials can cancel each other if we first factor out a -1 in one of them. So what I'm going to do here is I'm going to write it like this. And then let's say we leave this one intact, x minus 7 over 1 times 7x. And here we're going to factor out a -1, leaving us, and then we flip the order of the terms, so it leaves us with positive x minus 7. And now we can go ahead and cancel this against this binomial. And so now we're left with the limit as x tends to 7. And we simply only have -7, right? Because there's a minus sign there, so it's going to be -7x. That's all that's left. Now we can plug in 7 for x. So we're going to get -7 times 7 equals -49.